Hello and welcome to today's 1 p.m. demo on magnets. My name is Allison with Arizona Science Center and thank you for joining us for our live 1 p.m. demo. We have it every day here on Facebook Live and today's topic is magnets. So what do you all already know about magnets? Well, you might have some magnets in your house, which might be a good hint. So if we think about magnets, we know magnets, sometimes are stuck to our fridge. We think about magnets, they can be naturally occurring, they can be artificially made, but what are they and how do they work? So today we're going to be looking at what are they, how they work, and then also how to create your own electromagnet. So I have a simple bar magnet here. So we know magnets, they have a magnetic field around it, and it's something that we can't see, but I'm going to show you how we can see it in a few minutes. We know magnets, we have a north pole and a south pole. So we know that a north pole, what happens if a north pole goes near another north pole? Well, they're going to repel. They don't want to stick together. And a south pole is going to repel a south pole. What about a north pole to a south pole? Well, these two are attracted to each other. But if we look at magnets and look at the things they are attracted to, I have another type of magnet. This also has a north and a south pole. What kinds of things do magnets attract? So we know magnets attract to each other. So they have this invisible, and you can even hear that attraction. They have this invisible magnetic field around them that's going to attract and repel different items. But what kinds of items would even be attracted in the first place? So if we think a rubber band, is a rubber band going to be attracted to the magnetic field of this magnet? It is not. And if we think something else like a paper clip, it is. So even though these magnets have a magnetic field, there are some things that are attracted and there are some things that aren't. So if we look at something like a binder clip, it is going to be attracted to this metal part, but what about the plastic part? Ah, this one, it is. Interesting. Let's look at some scissors. We'll see how it attracts to the bottom, but it doesn't attract to the top. So we're noticing this trend. So for an item to be attracted within this magnetic field, it needs to have certain properties, primarily that it's going to be metal. Let's explore a little bit more about kind of why that happens and how that happens. So I have a bar magnet. We're actually let's look at this magnetic field so we can talk about it and understand it a little better. With this magnet, I have my north pole and my south pole, so I'm going to come down here, putting my bar magnet on the table, putting a white paper plate on top. See, nice and centered. Now I'm going to pour some things called iron filings. So these are little pieces of iron. So we noticed before that metals are going to be attracted to these magnets, where those rubbers and plastics, not as much. So what are they even attracted to? So we have this invisible field around it that some items are attracted to and some items are not. So let's look at this invisible field. These tiny, tiny pieces of iron are going to be a little more sensitive. So we should be able, I'll pour a little bit more on here, we should start to see some of this field. What are we seeing here? All right, so this is one way we can actually see this invisible force field that is around this magnet, which gives it its real magnetic property. So that invisible field that attracts and repels. So if we look at these ends, so we have the north pole, so we see a strong concentration over here. We have the south pole, which, the bend of the paper plate stops us from seeing it super well. But we can start seeing, even within this bar magnet, do you guys start to notice these curves? This general trajectory? They're not perfect curves right now because this magnet is not super strong. On a super strong magnet, you can really see these curves. But with this, we start to see the magnetic field. So things that get within this magnetic field are going to be attracted to the magnet. Now, if something is way out here, not going to be attracted because it's not within this magnetic field. Now, when we get to the middle of this magnetic field, we start to notice some things that are pretty interesting. We said there's a north pole and a south pole, and we know that north and a south are attracted to each other, and we kind of start to see this forming in the middle because as our poles begin to meet, this middle section, you see it starts curving towards each other. So when we think about that, we know these strong poles are what's going to attract and repel. If we put something, let's take my other bar magnet, if I put something in the middle of it, this paper clip, not going to be attracted in the same way as if it was on one of the ends, because it's just not as strong in that middle, because it's going to be attracting to each other. So think about these, it's very complex and very abstract, so the easiest way to think about it is these are like the lines of attraction and repulsion. If something falls within that, it's going to help be able to attract and repel, and if not, it's not going to be able to attract that object. Now, we're looking at this magnet and at this magnetic field, but has anyone ever heard of an electromagnet? So we're going to look up, we'll bring the camera back up here. So with an electromagnet, we can actually use electricity to produce this kind of effect. So we can create a magnet that can turn on and turn off. What kinds of uses could you think of for an electromagnet? Has anyone ever seen a super high security door where they push the button and then the door can suddenly swing open? We see those in movies all the time. So those are often advanced electromagnets. When the electricity is flowing, that magnet is really sticking those things together, because that magnet has a really big magnetic field and it's really strong. But you can turn off that magnet because you're creating a magnet from electricity. So let's look at how we do that. If we have a piece of wire, right now this is just a piece of wire. But when I put a battery, attach a battery to it, we attach it to the North Pole, attach it to the positive and negative ends of the battery. Just thinking about magnets still, guys. We can have an electric current start flowing through this wire. Now this electric current produces a very, very small magnetic field. So it's not really going to do much for us right now, but we can amplify that and create an electromagnet. So if I have an item made out of iron, so this is an iron nail. Iron is a really great material for creating electromagnets out of. I can wrap this wire around, and every time I coil around, this tiny magnetic field that this electric current produces is being amplified, it's being increased. So the more times I go around and around and around, I'm creating a bigger magnetic field produced by the electric current. So that takes a little while. So I have one pre-prepared already for us. So I twisted it around and around and around tons of times. So I have all these different coils, and all these different coils, think of them as each having a tiny, tiny magnetic field. But put all together, we're creating this bigger magnetic field. We can actually turn this nail into a magnet. So if I attach this to the battery, so once again, connect to the positive and negative sides of the battery. So we have the electrons, because electricity is made up of flowing electrons. These electrons are flowing through the wire, then they're going round and round and round, lots of circles going back to the battery in one large circuit. And this is producing now a magnetic field. So if I go to my paper clip, I can, it's not a very strong magnetic field. I can actually pick up a paper clip using this nail. Now, regular nail, not gonna pick up, well, I can loop it around, but unless I loop it around, it's not gonna pick up a paper clip. But because I've magnetized this, I can pick it up. But if I get rid of the electricity, the paper clip is going to fall, because this electromagnet no longer has electricity flowing through it, so it no longer has that magnetic field. So if you think of that on-off switch to open and close a high security door, that's going to be when the power is there versus not there, because once we disconnect the power, we disconnect the magnetic field, essentially. So this is something you guys can try at home. And what's really fun to experiment with is how the number of coils actually impacts how many paper clips you pick up. So if I have something with only, 2 or 3 coils, do you think this is going to pick up anything? Test it and see. But if I have something with all these coils, you can count. What if I have 50 coils? What if I have 100 coils? What if I get crazy, find a giant iron nail, and do 250 coils? Can I pick up 10 paper clips? Can I pick up something bigger than a paper clip? It's a great exploration that you can do at home to see if you can create an electromagnet. All you need is some wire, a nail, a battery, and some things to pick up. So a great way to explore electricity and magnetism at home. Just be sure you're safe and have an adult help you if you are a younger friend. So today we talked about magnets. We started talking about basics of a bar magnet, what a magnet sticks to. It's going to be attracted to these metal objects, not the other objects. And all of this attraction and repulsion is due to this really cool magnetic field that we're able to see using the iron filings. We know magnets can be natural. There are magnets found in nature, but there are also magnets that can be man-made. We didn't walk outside and find this. Someone created this. We also talked through how to make an electromagnet. So thank you all so much for joining us for today's 1 p.m. demo. There are tons of resources at azscience.org. I hope to see you again sometime. Have a great day.